This is Harcourt and welcome to my YouTube channel, Harcourt University. In today's episode, we are going to discuss dynamics of solid mechanics. So, what is dynamics of solid mechanics about? Solid mechanics. The dynamics comes before the solid mechanics, right? So that means there is mechanics, there is solid mechanics. And this is the dynamic part of solid mechanics. We have fluid mechanics, okay? And in fluid mechanics, we have the dynamics and what? Statics. So, what is mechanics? All right. So mechanics basically deals with mechanics. It's a physical science, right? It's a physical science that deals with the effects of forces on maybe bodies. Okay, so yes, this is mechanics. Now, if the body is solid body or rigid body, they are talking about what? Solid mechanics. If the body is fluid, they are going to have what? Fluid mechanics. Now, what about the dynamics? So, in simple terms, if the force is going to cause the body to move, so if the force causes the body to move, then you would want to what? Understand how the movement is being done, or you would want to analyze the movement of the body. And in doing so, you are doing what? You are studying what? Dynamics. So you use the quantum dynamics to analyze the movement of a body, right? Due to the effect of certain force or certain amount of force you've applied. Now, if the force does not cause the body to move, then the body is going to resist the force, right? So in that sense, you have to analyze the static effect, which is where you use the static concept, right? With strength of materials as well. Okay, right. So yes, we are not going to talk about strength of materials here, obviously. So yes, we've talked about what mechanics says. So mechanics is a physical science, that deals with the effects of forces on bodies. Okay. Now, yes, we've established that for dynamics, the body is going to move. Now, we have to talk about what motion is. So motion is basically movement, right? So motion is what? So when the body moves, yes, the body has has performed motion. Okay, the body has performed motion. So motion means movement. Okay, now what is displacement? Okay, so if the body moves from one place to another, let's say I have point 1 and point 2, right? And the body moves from here to here. All right, we are interested in knowing how B has moved away from the initial position A. Okay, so if someone asks, where is B with respect to A? So where is B if you're comparing B to A? B is on the what? Right side of what? A. By what length? Okay, so let's measure that length and say 5 meters. Okay, so B is at the right side of A by what? 5 meters. So this is a position B is relative to or compared to what? A. Now, if I ask you, by how much distance is B or has B moved away from what? A? That is what? 5 meters. Now, suppose B comes back to A, position A. Let me name that B prime. Now, the total distance B has traveled, you ask, by how much distance has B moved? That is going to be the first 5 plus the next 5. But when we ask you, by how or where is B at this current position compared to what? A. B is at the same place as A, right? So in the first scenario, or when we move from here to here, B was at the right side of what? A. So right side and what? 5 meters. And the other one, that when we ask for the total length B covered, that is what? Just 5 meters. So these two, you realize that one tells you the direction where B is, and the distance or the magnitude of length between A and B. And the other one just tells you the total was magnitude of length covered by B. All right. So if you change position and you want to look at the change in position in a particular direction, then we are talking about displacement. But if you just want to know the total distance you've moved by that motion, that is what? Distance. So we can say displacement is what? Just a change in position in a specified direction. In a specified direction. Okay. And distance, on the other hand, what is the total length covered by an object or a body. Okay. So the next thing is what? Kinematics and kinetics. Okay. There are two ways to analyze the system. So you would want to discuss the motion of the body without looking at what caused the motion, right? So you just want to analyze the velocity, the displacement, the acceleration without looking at the forces that cause the body to move in the first place. The other way is to looking at the force that applied to cause the body to move. So if you are looking at the motion of the body without considering the applied force or the cause of the motion, then you're talking about what? Kinematics. All right. Now, if you are looking at the cause of the motion, then you're talking about what? Kinetics. So kinetics is also a form of what? Dynamics, a concept under dynamics of solid mechanics that deals with what? The cause of what? Motion. And you know the cause of motion is what? Force. Because if you don't apply a force on the body wouldn't what? Move, right? You learned that force causes object to move or change position. Now, in this subject, we are going to talk about plane mechanics. So, what is meant by plane mechanics or plane motion is that we are actually going to work in two-dimensional frames. So we always have two axes perpendicular to each other. So you either have X and Y, or maybe a certain tangential line and it's a perpendicular line. All right. So all the time our velocity is going to be in two directions, right? So that's plane mechanics. So plane mechanics, we are not dealing with three-dimensional mechanics. So if you have, let's say, velocity, your velocity can only be in Vxi plus Vyg, right? It's always two-dimensional. Now, what is a particle? So in this concept, we would want to, so suppose I have a vehicle, right? I have a vehicle. Now, I want to analyze the motion of this vehicle. So before I begin, I can consider the whole vehicle as a particle without considering the size. So if I'm considering the total mass of the particle, let's say 50 tons, right? Now, 50 kilogram, let me say 50 kilogram. Now, with this 50 kilogram, if I am dealing with the energy, I have to look at the individual parts of the car. They are going to have their various energy and I will add them. I first consider the whole car as a particle, which has a mass of what? 50 kilogram. Okay, that means I'm just going to consider the mass of the body without considering the what size. So particles, we can say they are what? Substances. They are substances which have mass and what? Negligible dimensions. Okay, so or you can just say particles are substances which are considered to have mass and what? No dimensions or no size. Okay, yeah, no size. You got that. Okay, so we've discussed what motion is. You said motion is just movement of a body, displacement, movement in a specified direction. Distance is just the total length you covered during the movement. And kinetics, the cause of motion. Kinematics, we are dealing with the motion of the body without looking at the cause. And kinematics of particles, when you are dealing with the motion of a body without considering the effect of the force, and the particle under discussion or the object under discussion is just something that we are not considering its size but just the mass. Okay, and then yes, we've talked about that objects as what particle. Now let's get to work. So the next thing is talk about what. So I'm going to take the kinematics first. Kinematics of particles. All right, kinematics of particles. So we've already talked about that, right? We talked about the concept of kinematics of particles. So let's begin. So under the types of motion, we have the translational motion. We have the rotational motion. All right, now translational motion is when a body is traveling such that any line chosen on the body. So let's say we have block A, right? Let me use. So this block. Any line I choose on this block, let's say from this point to this point. So AB. If the block moves from point 1 to point 2, that line we had, so let's say A2, B2. This line and this line remain parallel throughout the motion. Okay, that means where the line is, so at position 2, this line, right, it should be parallel to this line. All right. So if you are moving such that any line chosen on the body remains parallel throughout the motion, then we have what? Translational motion. All right, look at this. If I have a body traveling from a line, you have a line like this. When the line moves from here to position 2 and it's still parallel to, so position 1 and position 2. If this line is still parallel to this line, then we also have what? Translational motion. So this is a line traveling along a curved path, but always remains what? Parallel to the previous position. Remains parallel to the previous position. Now, if that is happening, then we are saying we are having what? Translational motion. So translational motion can be in two types. We have the rectilinear motion, and what? Curvilinear motion. All right. So rectilinear motion is when you are traveling along a straight path such that any line chosen on the body remains parallel throughout the motion. And then the curvilinear motion is what? A translational motion where the body moves along a curved path such that any line chosen on the body remains parallel throughout the motion. I usually explain to students how they can also view curvilinear motion, not to confuse it with what rotational motion. If we look at, let me bring this guy. If we look at this, if I have any curve, let me just use. If I have any curve in this something like this, right? You realize that we are moving forward at the same time, what? Moving upwards. Until we go here, we're moving downwards and not moving forward. So you see, in this plane, we have motion in the x direction and motion in the y direction. So it's like we are having straight line motions along two perpendicular axes at the same time. So we are traveling along two perpendicular directions at the same time. When that happens, they are going to have what? Curvilinear motion. So anytime you're moving along a curved path, you are actually moving in the vertical and horizontal directions, or a tangential and its perpendicular directions at the same time. Okay, so with this one will be clearer when we are talking about the projectile motion. So you realize that in projectile motion, we talk about the horizontal motion vertical motion. You see, so you can generate equations for the horizontal motion, can generate equations for the vertical motion. In that we are having two rectilinear motions along what two perpendicular axes, and then the underlying word is what at the same time. All right, so you can view curvilinear motion as two linear motions on what two perpendicular axes at the same time. All right, so this will at least clarify the idea that curvilinear motion and rectilinear motion are all examples of what translational motion. Now, what about rotational motion? So rotational motion is when, obviously, if translational motion, the line remains parallel throughout the motion, then rotational motion, the body wouldn't. So let's say we have this box, right? Now, this box is hooked to a certain point here. So if I choose that line, I have point A and point B. Now the body moves from this position to this position. So realize that now our A2, B2, this line is not parallel to this line. If it's parallel, if it will be parallel, it should be like this, right? Something like this. But now you could see that this line is inclined to this line at a certain angle, right? At the center of what? Rotation theta. So for rotational motion, yes, there should be a fixed point where the rotation is happening about, but curvilinear motion is along the curved path. Translational motion and rotational motion are the two forms of motion. And under translational motion, we have rectilinear and curvilinear. All right. Now we may have a body that is what translating and rotating at the same time. So suppose I have something like this. I have this bar, right? And then I have a sleeve. One is like this. And this one can move up and down here. At the same time, the sleeve is what's rotating about this point. So realize that, I think that the shaft, this is a shaft where this one is on it. This one can slide up and down. So if it's sliding up and down at the same time, the shaft is rotating with angular velocity. Then this part, let's say the part A, is describing both what? Translation and what? Rotation. Okay, so if that is happening, then we have what? Complex motion or coupler motion. All right, so that is what will give us the third one, but usually it is the first and the second combined. So the rotational motion, we know. Now suppose the body changes position from position 1 to position 2. Let's say we move from here to here, right? So there is a change in what? Distance. Suppose distance is x, there's going to be change in what? Distance x. Now this will take place within some amount of time, which is what? Change in amount of time. So let's say theta t. Okay, so yes, velocity we've thought is thought to be what? The change in displacement over change in time, right? And distance is change. Speed is the change in distance over what? Change in time. So here our velocity is going to be what? Change in displacement over change in time. All right, now what is about this? You see, what they are saying is that suppose I cover 10 meters in 2 seconds, then my velocity is supposed to be what? 5 meters per second. All right, this is not bad, but this is called average velocity. Average velocity. Why? Because we are considering the average distance covered in 1 second. So you see this one can be written as what? 5 meters over 1 second. So we are considering the average distance covered within what? A second. All right. Now we would want to know the velocity when we had a very small change in time. You get that? So you want the velocity when what? Change in time was almost zero, or was not what? Zero. So this we have to find what? The limits of the expression change in x over what? Change in time. Yes, and if you remember your calculus class, we said this one will be equal to what? Dx dt. All right, so this velocity is what you call what? Instantaneous velocity. You get that? instantaneous velocity, meaning for every little change in time, you can be able to determine what? The velocity v. You get that? This is the average velocity. This is what? Instantaneous velocity. And majority or most of the discussion you're going to do is going to be based on what? Instantaneous velocity. In that, we would want to know the exact velocity at that particular point. Here is an average velocity. So if they are given total displacement to total time, you can just get the average velocity. But here, you need to what? Find the right velocity as in that little change in time. Okay, so now that we understand this, we don't even have to do a lot of first principle concepts. We know that acceleration is equal to what? dv dt, right? Which will be equal to what? d squared x dt squared. This is not really necessary, but just to know. So acceleration will be equal to dv dt. Now there is another way we can write what acceleration in terms of velocity and displacement. Look at something. A is equal to dv dt. If I multiply top and down by dx, I've not changed anything because this and this can cancel to give us 1. Now I'm going to switch the denominators, giving me dv dx multiplying dx dt. See, what term does this one give me? Velocity, right? So A will be equal to dv dx multiplying v, which is to say A is equal to dv dv dx. Okay, so let's quickly take an example and see how that goes. So suppose we have a position r given by in terms of t as 3t cubed, for instance, minus 4t squared. Okay, and they ask you to find the velocity. Now, this is displacement or position of a particle, which is dependent on time. Okay, so if they ask us for velocity, now you know velocity is what? dx dt. But in this case, our displacement is given as what? R. Therefore, velocity will be equal to what? dr dt. And that will be what? 9t squared minus what? 8t. You got that right. Now, acceleration, yes, acceleration will be equal to what? dv dt. You've been given v already, which is what? d dt of 9t squared minus 8t. And this will be 18t minus what? 8. So for any time, suppose they ask you to find the velocity at t equals, let's say, 2 seconds. Then you substitute t wherever you see it. So 9 into brackets 2 squared minus 8 times 2. And then whatever you get to be the answer for the velocity. Now they ask you for acceleration now, so you put 2 here, making what? 18t, 18 times 2 minus what? 8. And you get the answer as well. So yes, this is it. So the main equations we have are what? dv dt, dv dt, yes, dx dt, and then what? v dv dt. Okay, now sometimes you see, even in this, acceleration is what? Is time dependent. So this acceleration is going to be a variable acceleration. Okay, variable acceleration. In that acceleration here is dependent on time. So in 1 second, the time is different from 2 seconds. Okay, and there are instances where the acceleration is constant. Okay, the acceleration is constant. So I want to solve questions that are acceleration dependent. Acceleration as a variable and acceleration as a constant. So yes, for the variable accelerations, you just have to stick with the differential terms, right? The expression. So A equals v dv dx, and then A equals dv dt, and v equals dx dt. Meaning the question will come in the form that acceleration is a variable. So to solve this question, you have to use the integral or the first principle approach. Now, in some situations, the question will come as what? Constant acceleration. As for instance, projectile motions or motions under the effect of gravity. Acceleration is constant. Even most of the cars and all that, at a particular instance, let's say a vehicle you are driving a vehicle. At a particular instance, how much you press on the accelerator is how much the car is going to move. So the acceleration of your car is dependent on your leg, right? Not time. So within a specific time interval, you will have a constant acceleration. So with that interval of time, if you want to analyze the motion of the system, you're going to consider the system or the motion as constant acceleration motion. So we would want to generate some equations that you wouldn't always have to use the first principle when you are given questions under constant acceleration motion. So yes, there are our differential equations. We have A equals what dv dt. We have V equals dx, or let me use S, right? We have ds dt, and another one, A was equal to V dv ds. Okay, so suppose a body is traveling with an initial velocity u and an acceleration a, and it attains a final velocity v after covering a distance or displacement s in a time t, right? dv dt is equal to a. So if we want the velocity, we can say dv equals what? A dt. Now we said this is what? Constant acceleration motion. Okay. So dv equals what? A dt. Now you integrate both sides. Limit is uv. Here limit is 0 to t. So if you integrate dv, you get v, your limit is u to v. If you integrate a dt, you get at, your limit is 0 to t. So you're going to get v minus u equals what? At, which gives us v equals u plus at, equation 1. Okay. Now, this means we can tell the final velocity, knowing the initial velocity, the acceleration, the time taken. Okay. Now, we would want to also tell the displacement, right? So we know that v equals what? ds dt. So this implies that ds equals v dt. Now, ds will be equal to v is what? U plus at dt. We integrate both sides from 0 to s. We integrate both sides from 0 to t. So we're going to have s limit from 0 to s equals ut plus half at squared from 0 to t. Then that's to give us s equals ut plus what? Half at squared, equation 2. Right. The next is the other guy with it. Okay. So in the previous equations, I said we can have a equals what? V dv ds. All right, so we can multiply a by ds and say is equal to v dv. Okay, so having done this, can integrate both sides, and this one give us as from 0 to s, giving us what? V squared on 2. Oh, the elements has to come from u to v. So this one give us as equals what? V squared on 2 minus u squared on 2. So you can multiply 2 by 2, giving us 2as equals v squared minus what? U squared. Now if the u goes to the other side, we have v squared equals u squared plus 2as, ratio 3. Right, so usually we call these equations of motions, but equations of motions are actually the F equals max, ma, right? These are equations of motions. So I don't know how to call this. You can say they are equations of how do you call this? Constant acceleration equations of motion, maybe anyhow you want to call it. All right, so these equations we could just ignore them and always come and start from this level, but we just want to generate this equation so that when you are having a constant acceleration question, You wouldn't have to start or do all this. You just have to quote the equation and put your values in it, and you are gone. All right. So yes, this is the concept.